A small circle and a square of area, 144 centimeters square, are inscribed in a semicircle. What is the area of the semicircle in terms of pi? Also, find the radius r of the circle. Solution. Let L be the length of the inscribed square. Thus, the square of L equals 144 centimeters square. This implies that L equals 12 centimeters. Let O be the center of the semicircle. Label A, B, C, and D. Join OC equals R. OB equals the difference of R and 6. From triangle B, OC using Pythagoras' theorem and substitute values. We have that the square of R equals the square of the difference between R and 6 add up to the square of 12. Simplify and solve for R. For question I, area of the semicircle, A equals the product of 225 and pi all divided by 2 centimeters square. For question 2, join DC equals the product of 12 and the square root 2. And angle CDB equals 45 degrees. Recall that OC equals R equals 15 centimeters. Consider triangle DOC. Using cosine rule, we solve for DO by substituting other values we have found. (225) is equal to 288 plus DO square minus the product of 24 and DO.
Let D O equals X.
Substituting in the equation, rearranging terms in one side of the equation and factorizing, we have that x minus 3 is equal to 0 or x minus 21 is equal to 0. X equals 3 or x equals 21, but x equals DO. Thus, DO equals 3 or 21. DO is not equals to 21. Thus, DO equals 3 centimeters. Label H, which is the perpendicular line to line E, D, and label G. Join G, O, and label K. Consider triangle KOH using Pythagoras' theorem, substitute values, open brackets, multiply out, simplify and arrange all terms in one side of the equation. Solve for R using quadratic equation formula. Simplify further and factorize. Take the positive result. R, the radius of the red inscribed circle, is equals to the product of 6 and the positive difference between the square root of 15 and 3 in centimeter.